Assam Boudjelthia. I work for the Qt company. I joined the company almost a year ago. I've been working on the Android port for Qt library and the Android support for Qt Creator. So in this webinar, getting started with Qt for Android, we'll go through a quick overview how to set up the environment and how to use Qt Creator to develop Android applications and exploit the Android features that Android offers. So an overview of what we'll go through. So we'll show how to set up Qt Creator and manage the Android kits. Then we'll show how to create a simple application and how the packaging and the deployment is done with the Android Deploy Qt tool. Then we'll go a bit deep on how to extend Qt for Android to use more advanced Android features. And then we'll show how to use resource management, and then how to communicate and exchange data between Qt and Android with Java. And lastly, we'll go through an example for services. So if you have already a Qt Creator and you set up, you install Qt for Android package for the first time, you will be greeted with this notification below here to configure Android. So what will this ask you is it will look for a valid Java path and an Android SDK, which are used to build the Android applications. So the SDK is used, has the SDK build tools and the platform tools, as well as the NDKs that are used to actually build the application. Also, you could see here in Qt Creator there are a list of the available NDKs. You could also add custom NDKs in here. If you want to start fresh with an SDK, you could type the path in here and click the setup button in here. It will then set up the SDK and then install any necessary application packages for you. And of course, Qt Creator, starting from Qt Creator 4.12, the NDK selection is done automatically. So we had previously issues with NDKs being not compatible with some Qt versions. So Qt Creator will handle that automatically starting from 4.12. So what Qt Creator does for you is it will create Android kits for you, which are populated with the debuggers and then compilers and the Qt for Android versions. And these are created automatically. It could be used to build and debug your applications. And as well, you could always add the custom NDKs and create custom kits if you wish. So Qt for Android applications follows the same approach as any Qt applications. So if you want to create an application, just go select the new project, and then let's select, for example, scroll. And then in the wizard, make sure to not select Qt Virtual Keyboard, since this is an option only valid for boot to Qt devices, embedded devices, and since Android devices have their own keyboard, so there is no need for that. Then if you select an Android kit and then run, it will Qt Creator will show you a device list. You can select the device or Android AVD virtual device, and the application will be ready. So under the hood, Qt Creator uses the Android Deploy Qt tool that is responsible for packaging and compiling the application and packaging the APK binaries. So Android Deploy Qt handles the resource management as well. So it will copy over any resources, images, QML files that you have on your application, as well as dependencies for the Qt library, such as Qt Quick, or Qt location, for example, it will put those in special directory folder that is then built using Gradle, and and then it will generate the APK and install it on the device and run it as well. Qt Creator also supports ABB binaries in addition to APKs, which can hold one architecture. So ABB packages are used by the Play Store to serve different architectures for different devices. So you could always build AABs from project and then build Android APK and select this. And also you could sign packages with the UI provided. So now we can go through how to extend Qt for Android. This is an important topic for Qt for Android. So because Qt doesn't cover all the features that Android offers, so Android with the NDK offers what's called Java Native Interface, the JNI, and it is used to call functions and trigger function calls and exchange data between native C++ code and Java and Android and APIs. So Qt library on itself is built on top of that. So Qt on itself is consists of some Java classes that will create an activity and handle some rendering and events and pass them over to Qt. And this is all done using the JNI. So you could create Java code, use Java libraries, and communicate between both worlds. To use this, to extend your application, first of all, you need to create an Android package directory format. So in Creator, does that allow you to do that easily? If you go to projects and then build Android APK, there is a button here to create templates. What this will does, it will create a bunch of files and add them into your project .pro, and then it will add a manifest and a bunch of Gradle files that are used for building the packaging the application, as well as any resource files. You could add the resources, images, or Java code inside here, and the formatting here is the same as any Android application. Also, the most important variable in here is the Android package source tier. So this holds the path to this package directory. So this must be included in the project to be able to use that. And so using this, you could add Java code, any assets, icons, layouts, basically the same structure that any Android application follows can be under that folder. Also, Qt Creator offers you a UI for the manifest editor that allows you to edit names and versions and application name and icons and add permissions easily. Also, if you want to extend beyond this, you could always go to the XML source and it will give you a more advanced view for the XML to edit. Also, Qt for Android, in addition to the Qt resource system using QRC prefix, allows you only for Android to use the Android assets system. So by default, the Android package under the Android then assets path allows you to add any assets such as pictures, for example, and then in runtime you could use those assets. In Qt, you could instead of the QRC prefix here use assets, and then the same in QML, and then this will allow you to take advantage of the assets system. But be careful that this is only specific to Android and not for all Qt. Then one thing that is used a lot is if you want to extend some Android features is you need to implement some logic using Java and then call it with C++. So if we start here, we can have some custom class that has one member function to print some hello world string to the terminal. So to use this from our Qt C++, we will define a function and call it this name and use Qt Android that is part of Qt Android Extras. Then we will create a GNI environment, and then we will use the find class to find the reference to our class that we defined in here that is part of the Android package. Then we'll create a GNI object from that reference, and then we use the convenience method, call method, and give it the name in here. So what this will does is call the Java function from within the C++. The same, so to extend that from C++ to QML directly, so we could define that C++ class in our QML as a property using set context property. We will call it playground. And then inside QML, if let's say we have a button and then on clicked signal, we will call that call custom class that is defined in C++. So this will extend QML from QML to C++ to Java. Then the same applies, and probably it's a bit easier when using static Java methods. So in that case, you just need to call do one line code call static method. But in here, we need to provide the class name, the function, and then the signature. Be mindful that the signature has to be exactly the same, and the Qt for Android documentation has some guidelines on how to structure this signature. Then we can. There is one other concept which is native calls from that the GNI offers. So Qt 5.15.5.0 has will include an example called Qt GNI Messenger. So what this will show is how to exchange data from both ways, from Qt to Java and then from Java back to C++. So this example basically triggers a call to Java, then Java will send a different message back to C++ and then back to QML that will be displayed on the view. So in the Java side, let's just define a custom class called GNI Messenger with a method that we will populate later. And then we will define this method and give it the keyword native. This will ensure that this will be called back to C++. And then in our C++ side, we need to do what's called as register native functions. So we need to register that Java function. So we define a native GNI native method array and give it the name and the signature for the Java class, and then give it a pointer for the C++ function. So this Java function will then be called to the C++ function, which is this one in here. And then we will need to call the register natives and give it both the class reference and the methods array. And this has to be done, of course, before any call to using that native call. Then the same approach to register the C++ property to QML. We use that context property. Then in QML, we will call the print from Java. So this call will go to C++, and then we'll trigger the Java call. So this basically will include, we will create first a Java string using our helper functions that are part of Qt Android Extras. Then we will call the method print from Java in here, same as before. Then in the Java definition for our function print from Java, this will basically print the string with the message that we received from C++. Then this second line, what it does, it will call the native function that will send another string hello from Java back to C++. Then in our C++ callback function that we defined, we basically will emit a signal called message from Java to QML. And then in QML, there is one thing that we need to do to make this connection full. So we need to define the connections component and define a function event for the and call it on message from Java. So this will wait for any signals from this message from Java. Then basically it will output it to QML, and the cycle is full now. So one thing to notice when using the register natives, so in our previous register natives, what we did is we defined the register natives in the constructor for our class. There is another, that is one way, but there is another way, which is using this call function called GNI onload. So what this function call here will be called directly after loading the shared libraries. So once Qt for Android application is run, the activity will load all the shared libraries that Qt uses. And then after those libraries are loaded, this function will be called. So we can take advantage of this and define the register natives directly in here. So the advantage of this is you don't need to worry about registering the natives, because it will be done first thing after loading the shared libraries. On the other hand, if you register it manually, it might be such that you might end up calling the native before the registration. So that's one advantage of using the GNI onload. But this approach in here will only be called once per shared library. So you can't call it twice or define it twice or something like that. So let's move on to another good topic on Qt for Android, which is services with Qt. So Qt for Android can implement Android services and communicate between them using different ways. One way is the one that we discussed earlier, using directly native GNI calls. Another option is using broadcast receivers, and then you could also use Qt remote objects or Qt Android binders. And the same rules here apply. So Qt for Android services can run in the same process as the main activity or in a separate process. And they could also be called from the same shared library, or the service could have its own shared library. And in the case of using a separate shared library, the service has its own like sub-project. And one thing also to remember is that when using Android services, you always need to use the Q Android service loop app program loop instead of the normal Q GUI application, for example. With let's see an example with the Qt services with remote objects. So we will define a Java class for our service. It's just a Qt service that extends Qt service, and then define the default functions. Then in the main application, we need to start this service. So one way is to directly from C++ create an intent for the service using helper functions, helper class, Q Android intent, and then call the call object method to start the service using the method start service from the main Android activity and give it the same signature and then the intent that we created. Note also that you can create a Java code that starts the service and call it directly from using a normal GNI call as well. So we won't go deep into how to use Qt remote objects, but Qt remote objects usually needs a class definition. In here, we have one slot for send to service, and then once we receive a message, we will directly emit back a signal called message from service with hello, then a name. Then in the service main function, we need to create a host node for the remote object with this address, and then we need to create an instance for our app class in here. And then in the main application, the app with the GUI, with the view, we need to connect to this node using a replica node in here, and then register it to QML using set context property as before. And after registering this, then QML will have access to the remote object, and then they could communicate and send data between each other. So one last thing that needs to be done to be able to start the service is you need to define the service metadata in the Android manifest file. So you need the most important pieces are the Android process in here, which contains a name for the process, and then the name of the class that we defined as our service. Then we need to provide the applib name. This is the entry point for the service, which is our sub project called service. This is different from the main application that has the GUI. And then we need to add this metadata in here that will basically make sure to load the Qt libraries that are used to handle Qt remote objects, for example. And lastly, we need to define this background running as true to make sure that service can run in the background. And of course, these snippets of code can be seen in the Qt 5.15.0 documentation that will be released soon. So lastly, there is one thing that is asked usually a lot is, for example, when to use Qt service or just the normal Android service. So Qt service, or for that matter, Qt activity, what it does, it makes sure to load some Qt libraries and handle events and gestures and such, and communicate those between Qt and Android. So the general rule is if you have any Qt specific features or you have any native calls, you need to use the Qt service. Otherwise, if you have pure Java implementation, you can just use service and it will run just fine. Also, you could see more info about services and GNI calls in our documentation. And one thing to note is that Qt Creator will have some UI for handling, creating, and editing services in the next releases. So stay tuned for that. So with this, I thank you all for listening, and we welcome any contributions or suggestions, and I will be open for any questions related to this now. Thank you.
Great, thank you, Assam. So just a reminder, you can send in your questions via the Q&A button at the top of the interface. I think there's already some questions in.
Okay. So there is a question, any possibility to generate APK with application specific name instead of current generic one? So currently the default name is used, and there is a suggestion already in our backlog to handle that. So currently that's not possible, but we'll make sure to handle that in the next releases. Also. So there is another question. Please describe the approach of adapting Linux QML applications for Android. Should it be separate source code, or I can adapt my current code with some ejections or for Android OS? So usually the same QML applications for Linux, for example, or Windows or such can run directly in Qt on Android. So unless there are some specific features that Android handles differently or are not available on Android or such, so in that case you need to handle those using as you call it, injections. You can use custom code specific for Android, but basically the same QML application could still run on Android. Depending on the case.
Yeah, there's quite a few questions there.
Some of them are long, that's why I'm.
Yeah, no worries.
So there is one question here. I plan to make a desktop and Android application. What is the best way to write it once, desktop, and then transfer to Android, or both at once? So the same applies in here. So if you have any Android specific features that are included in the application, you need to handle them using the, as described, using the Android package, the custom package. Otherwise, if the application uses a more generic Qt features, then you could write the code once and use it on both the platforms. But one thing to make sure of is that you need to handle, for example, the UI restriction layout. So you need to make the layout a bit dynamic to make sure that it handles both the big screen of the desktop and the different sizes of the mobile platforms. But it's possible to write the code once and then use it both. So is Qt 6 CMake support for okay, it went away. Is it? So there was a question: is CMake support for Qt 6 for multi ABIs available? So CMake should already handle multi ABI build with Qt 5.14. There is So are there any option to gather in crash reports from C++ code, like crash lytics? Unfortunately, I'm not aware of such reporting mechanism.
I think we have time for a few more questions.
Okay. So there is one question. We are trying to build an app using Qt QML, but we run a basic Qt app application on Android. There is blank screen with a black title bar with the app's name that appears for a second. Just before the splash screen, it's a game blocker. I'm not sure I get the full picture of this issue, but I think for this it's better to discuss it later, or maybe create a bug report for this, and we will be glad to handle it.
Okay, I think we have time for one more question, and then unfortunately we're running out of time here.
Yes. So how to set QWidget UI to auto resize to Android display devices? So with QML you can make the elements a bit dynamic and set in the design you could set the sizes dynamic and use them across your application, and QML also elements have layout and constraints, so you could use those to design your application, but it's better to take them into consideration from the start of the development of the application.
Okay, thank you, Assam. I think that's all the time we have for today, unfortunately. For those who didn't get their question answered live, we'll follow up on those after the session. So I'd like to thank Assam again for your presentation. Please send us some feedback by completing the survey at qt.io/thankyousurvey. You can also join the next live session via the live event page, and also please feel free to chat to our Qt Professional Services on the live chat at the live event portal. So I'd like to thank you again for joining, and have a great day. Thank you. Bye.
Thank you.